discussed, right? We have discussed sum of two signed numbers. Okay, so how to add two signed numbers we have seen in the last class. So I guess I have given an example of adding -2, okay, plus 3, and -5 plus 3, and -4 minus 3. Okay, adding these two numbers. Is it clear to all of you? Am I audible?
Sir.
Okay, right. So this is what we have seen last time. Okay, so how to do it I have told. Now let's start from that point onwards where we have stopped. Okay, so let me do this again. -2 and -3. Okay, so -2, how it was represented in using 4-bit. So this is -8. Okay, -8. Then how you will get -2? -8 plus 6. Okay, so this is 1 2 4 -8. Okay, so -8 plus 6, right? It will give us -2. What about -3? This is -8. Okay, plus 5. So 4 1 5. So this was the conversion process of signed binary numbers. Signed binary numbers. These -2 and -3 happen to be negative numbers in decimal. So equivalent binary numbers, signed binary numbers are written in this way, right? Then if we go for taking sum of these two, this was 0 plus 1 1, this is 1, this is 1 1 0, and a 1 over here. So this one, and you get one overflow here. Okay, overflow here. So always remember, in signed bit representation, okay, the most significant bit. Okay, most significant bit means towards right, this one. Okay, in a 4-bit scenario, okay, let me write like this. Let me complete this. In signed bit representation, the most significant bit is called as sign bit. Okay, sign bit. If MSB is 1, it's a negative number. If MSB is 0, it's a positive number. Okay, so let's say B0, B1, B2, B3. Okay, we write a binary number like this. This is called as the least significant bit. This is called as the most significant bit. Okay, least significant bit this side, most significant bit this side. So for signed representation, if there is a binary 1 here, it is termed as a, the whole thing result is termed as a negative number. If you happen to have 0 over here, it is called as positive number, right? So let's conclude what was the result here. This overflow has to be neglected. Overflow has to be neglected. So you got 1011. Okay, so 1011 means what? So we got the answer 1011 in binary, signed binary represents. Okay, this is signed binary bits, signed binary represents. So what is its equivalent value? What
5.
we were doing, we were
Minus 2.
adding -2 and -3. Okay, we
Minus
were
5.
adding -2 and -3. Answer should have been -5.
Minus 5.
So if it is signed bit representation, the answer will be -8
Minus 8
plus
plus
2 plus 1. Okay, so this is like this, -8, this is 4 2 1. Okay, so 4 is not there, this is there, this is there, this is there. So add them, so you will get how much? It is -5. So if 1011 you would like to represent using unsigned bit. Okay, unsigned bit. If the same number happen to be unsigned one, okay, so what would have been the answer? It is 8 plus 2 plus 1, that is 11 in decimal. Okay, understand? So the number is same, 1011. For signed representation, the answer is -5. Okay, answer is -5. So randomly, if any number is given, randomly if I write any number 1011, okay, and ask you what is its decimal equivalent, what is its decimal equivalent, okay, by default if anything is not mentioned, we have to assume the given binary number is unsigned one, okay, default you should assume it's an unsigned number and give the answer. So it is equivalent to how much? 8 plus 2 plus 1. Okay, 8 to 10 plus 1, 11. If explicitly it is mentioned as signed number, okay, signed number. So what you have to do? This is minus 8 plus 2 plus 1. This is minus 5. Okay. If it happened to be result of sum of two numbers and all where we process signed numbers, okay, the answer will be according to Fusion, right? I guess it is clear to all of you. Okay. Now let's move to another thing. We have seen here an overflow, right? When we added these two number, there was an overflow here. Okay, there was an overflow here. So with signed numbers, two-way overflow can occur. Okay, two-way overflow can occur. We will take two more examples, and there are possibilities. Sometime we won't be in a position to detect the overflow. Okay, what are the conditions you're supposed to remember? Okay, we are dealing with a 4-bit scenario. Let's see, I'm writing the statement here. Okay, with signed numbers, two ways overflow will occur. Okay, if result is greater than 7 or result is less than minus 8. Okay, make a note of it. If the result is greater than 7 or less than minus 8. Okay, in this way the overflow is hard to detect. Okay, sometimes, and the result will also give wrong answer. Okay, let's do it. Take an example. I would like to add 6 plus 3. I would like to add 6 plus 3. So what would have been the result? It should have been 9. Okay, so I'm going for signed binary addition. Okay, signed binary addition, like last plus what we have learned. So in signed binary representation, plus 6, how it is represented? Okay, plus 3, how it is represented? So the first MSB is 0. Most significant is bit is 0. It indicate what? Both numbers are positive numbers. Okay, both numbers are positive numbers, right? Then go on adding this. This is 1. This is 110 1. Okay, 110 1. Right. So this is the result. But what result? Signed binary sum. It is signed binary sum. So what is its equivalent number? What is its equivalent number? What is its equivalent number? Minus 8 plus 1. This is what? 1, 2, 4, minus 8, right? Signed representation. This is minus 8, 4, 2, 1. Minus 8 is there. This is there. Okay. What you will get? Minus 7.
-7.
But what answer was expected?
9.
9. But what answer we get? Minus.
-7.
So in this way, there is a overflow here, but we are unable to detect it. Okay, we are unable to detect it. Okay, right. Another scenario we'll see, because here you see sum is greater than 7. This is greater than 7. Okay, that's why this type of situation arised. Okay, Let's take another example. Let's take another example. I will take -7, -3. Both are negative. Okay. What would have been the answer in decimal? It's -10, right? So I am following the same approach. Okay. I am following the same approach. What is that? Signed binary addition. What we have learned yesterday. Okay. So -7, how it is represented? -7 in signed binary representation. This is -8. -8 plus 1, right? Okay.
Yeah.
So 1001. So -3, how it is represented?
-8 plus 5.
-8 plus 5. So 5 means 4, 1, 5. Okay. So you please make a note here. The MSB is 1. Means what? It's a negative number. Okay. So we have both numbers as negative numbers. Last scenario, it was 0. So both numbers were positive numbers. Okay. So here it is 1. Okay. MSB is 1 for both cases, right? Then let's add it. What we are getting? 1, 1, 0. So carry 1. Okay. So this is 1. This is, there is an overflow here. It's visible. Okay. But what is, we supposed to neglect it, right? The overflow, it has to be neglected as usual. So what is the answer? This is the answer. So what is its equivalent value? It represents that the answer is a positive value because MSB is 0. Okay, MSB is 0. It means it's positive, right? What is its equivalent value coming? It's 6. 4 plus 2. It's 4 plus 2. 6. Is the answer
Sir,
correct? No, it's wrong. Okay.
sir,
Yes. Yeah.
roll number 6 and 63 are waiting outside the room, sir. They have some login issues and logged in now.
Breakout room is, I have removed breakout room. Where
Roll
they are
number
waiting?
26 and 63.
Waiting room is not enabled. And you, they can join, right?
No, that telling that you didn't accept, allowed them.
No, no, ask them to log out and log in again. I
Okay,
didn't
sir.
enable waiting room. They can join directly.
Okay, sir.
Okay.
Okay,
Right.
sir.
Okay. So all of you understood this. -7 and -3. Sum of these two numbers, the results would have been -10. Okay, but we are unable to get the correct result. Why? If the sum, this one, the sum. Okay. What is this? This is less than -8. Okay. If any value, any result value less than -8 or greater than 7, correct answer won't come in this approach. Okay. This answer is resulting into this value. Right. This is a note you have to make. For 4-bit scenario, I have given this 2. You can extend the same thing in 8-bit also. Okay. Try yourself. Now, in these two scenario, what we will say, overflow is harder to detect if two numbers with same sign are added. Okay, and the result has the opposite sign, an overflow has occurred. Okay, all of you understand? We are adding here two negative numbers, 1 and 1. If the result is having a different number, two negative numbers, here sign bit also should be 1. Means what? Negative and negative, it should have been negative number, right? But if it is coming 0, you should understand that the answer is wrong and overflow has occurred. Similar is the case for the previous example. See, it is 0 and 0, but we got a 1 here. Okay, we got a 1 here in the MSB in the result, right? That is what if the result has opposite sign, okay, an overflow has occurred. Opposite sign, when two numbers that you add have similar sign and the result has opposite sign. Here two numbers what we add are positive, result is negative, so it's an error. Okay, in this way we can interpret it. Here also two negatives were added and the result is showing positive, it's an error. Okay, right. So I guess this is clear to all of you. Now let's move to another topic called as signed bit multiplication. So signed bit addition we have seen. Okay, how two signed bits are added. Now let's go for signed bit multiplication. We have done unsigned bit multiplications, binary multiplications, right? So let me take one small example to refresh yourself. What we have discussed earlier is unsigned binary multiplication, unsigned binary multiplication. Okay, let's say 1111 and I would like to multiply it with 10. Okay, what you were doing? Okay, so 0 0 0 0 and this will be 1111, right? You were adding it, so you were getting the answers, right? This was the answer, unsigned binary multiplication. Okay, now in case of signed binary multiplication, what will be the change? Okay, what will be the change? Let's see. This was an example of unsigned binary multiplication. Okay, what we have already done with. So I have multiplied here 4-bit with 2-bit and we got some answer. Okay, so let's try signed binary multiplication. Okay, let's understand today signed binary multiplication. Okay, signed binary multiplication, right? I write these numbers here, -5 into -7. I'm interested to find out its result. Another multiplication I will do -5 into +7. Okay, and another example I will take 5 into -7. 5 into -7, right? Okay, am I audible?
Yes, sir.
Yes.
Right. Right. So these results, we will see what is the procedure to multiply these two signed numbers, where the first case is what, both are negative numbers. Here one is negative, one is positive. Here the other one is positive. This is negative into positive, negative into positive. This is positive into negative, right? So how to do it? So before going to this, okay, we need to know something called as 2s complement. Okay, 2s complement. 2s complement. So in binary, what do we mean by 2s complement? Okay, and before understanding 2s complement, we have to write 1s complement. Okay, 1s complement. So what is 1s complement and what is 2s complement? After you understand this, we will be in a position to multiply two signed numbers. Okay, so let's see what is 1s complement. Okay, so before going to this, let's take an example. I have taken a binary number 1011. Okay, I have taken a random binary number 101. What will be its 1s complement? Its 1s complement will be, just invert these bits, 0 1 0 0. Okay, this is the 1s complement of this number. Let's take another value 1111. What is its 1s complement? Its 1s complement is all zeros. You take another example 0110. What is its 1s complement? 1s complement will be 1001. Is it clear to all of you?
Yes, sir.
Right. Then what is 2s complement? 2s complement is 1s complement plus 1. Okay, 1s complement plus 1. So let's say for this example, I would like to find out the 2s complement. Okay, so what will be the 2s complement for this? Just add 1 with this 1s complement result. Okay, just add 1 with the 1s complement result. Okay, let's suppose this. So what you will get? This is 1 0 1. So for a value of 1011, this is the given binary number. Its 1s complement is how much? 1s complement is 0100. Okay, its 1s complement is 0100, and 2s complement is 0101. Okay. Understand?
Yes, sir.
Okay, let's do it for the second scenario.
Sir, can you
Okay,
explain the 2s 2s once again.
Complement again. Okay.
Yes.
So we will deal with this example. This example. So example 2. Let's I have a binary number 1111. Okay. Binary number. I would like to find its 1s complement. 1s complement. So what I will do? Invert all those bits. Okay. I would like to find 2s complement. 2s complement. Okay. So what I have to do? 2s complement is 1s complement plus 1. Okay. So what was the 1s complement value? It was 0000 plus 1. What you will get? Okay. So this is 0001 is 2s complement of whom? Okay. Understand? 4 ones are there. Its 1s complement is this. Its 2s complement is this. Is it clear to everyone? Is it clear?
Yes,
Or
sir.
shall we take
Yes,
one
sir.
more
Yes, sir.
example?
Yes, sir. It's clear,
Yeah.
sir.
Yeah. I guess it is clear. It's an easy process. Okay. It's an easy process. So in decimal, let's take a decimal scenario. 2-digit highest number in decimal, how much? 99, isn't it? So if I have a value, example, I have a value, decimal value 3. Okay, I have a decimal value 3. So if I would like to find 9s complement of this, 9s complement of this, means what? It is 99 minus 3. What will be the answer? 97. Understand?
96.
Sorry, 96. It's 96. Okay. This is called as 9s complement. So 10s complement, how to find? 10s complement is 9s complement plus 1. 97. Okay. So this is there in decimal scenario. Okay. So we have learned in binary scenario here. Okay, 1s complement, 2s complement. So in binary we have 1s complement and 2s complement. 1s complement means invert the numbers, all the numbers, and 2s complement means add 1 to 1s complement. Okay, add 1 to 1s complement. So I leave it for you to discover the logic how 1s complement is coming. I've explained in binary how you are getting 9s complement. Okay. Similarly, think yourself today and answer me tomorrow how you are getting 1s complement. I told you the easiest method to find out 1s complement. Invert those bits. But what is the mathematics behind that? Okay. Please think yourself. Then I will answer.
Sir,
Okay.
adding 1 and
Hmm.
leaving the overflow.
Adding 1 and leaving the overflow.
Yes, sir.
Okay. You think today whether it is working for all possible scenarios or not. Okay. I guess it won't work. Just try. Okay. I will tell you the correct answer tomorrow. I'm leaving it for you people to think how actually we are getting 1s complement. See, inverting all binary bits is giving the correct answer. But what is the mathematics behind that? Okay, please do think. Okay. So by taking this much basics, we will move to the multiplication, right? So all of you understood what is 1s complement, what is 2s complement. Let's solve one more example for your convenience. Example 3 I am taking. One more example. Okay, one more example. Let's take 0101. Okay, 0101. This is the binary number. So what will be 1s complement of this? It will be 1010. What will be 2s complement of this? It will be 101. Okay, I have added 1 here. Understand? Okay. Now with these fundamentals, let's move to signed binary multiplication. Okay, signed binary multiplication. So signed binary multiplication, what I told, I am interested to find out what is multiplication of minus 5 into 7. Okay, minus 5 into 7. So I'm multiplying a negative number with another positive number. Okay, I'm multiplying a negative number with a positive number, but I would like to represent these two both using signed binary representation. Use signed binary representation. Okay, signed binary representation. So how minus 5 is represented? How minus 5 is represented
1
in
0 1
sign?
1.
1011.
Okay, so let's do it in smaller font. So minus 5. Okay, minus 5 means equivalent value. This is minus 8 plus 3. Okay, right. So plus 7, how do you represent? 0 1 1 1. Okay, plus 7. Yeah, it's audible, I guess. Okay, so see, plus 7 means first bit is 0, minus 5 means first bit is 1. So I'm using signed binary representation. Okay, now let's multiply these two. Our objective was to multiply these two numbers. Okay, okay, multiply these two numbers. So what you will get? 1011 into 011. Okay, carefully observe the process. Okay, so first multiply with this LSB. Okay, last one. So what you will get? 1 0 right here, 1 0 1 1. Okay, now you multiply with the second one. Okay, what you will get? 1 0 1 1. Now multiply with the third one. Okay, what you will get? 1 0 1 1. Okay, now multiply with the last 0. Okay, we got this. Okay, we got this. Now what we have to do, like conventional multiplication, what we have done for unsigned one, okay, we have to do it in some other way. Okay, we have to do it in some other way. So last class I told you, while representing a negative signed number, or while representing a signed binary bit, okay, while representing a signed binary bit, if you increase the signed bit value towards the left, okay, example is, let's take this example here, say minus 5 using 4-bit signed representation. I guess yesterday's quiz also you might have got a question. Minus 5 is equal to 4-bit signed representation. What will be the answer? It is 1011. Is it clear to all of you?
Yes, sir.
1011. So if you represent using 8-bit, okay, if you represent using 8-bit signed representation, what will be the answer? What I told yesterday, 1011. Whatever is there in the signed bit, just increase them 4 times.
4 times 1 1 1.
Okay, so if you sum of these all, you will get the same answer. Okay, I have shown an example yesterday. Someone asked a query, right? So similarly, for minus 7, okay, for minus 7 or say plus 7, let's take plus 7. Plus 7, writing plus 7. What is its signed 4-bit signed binary representation? 4-bit,
0 1 1.
okay, signed binary representation. It's 0 1 1
1 1 1.
0 1 1 1. So if you like to represent using 8-bit signed representation, 8-bit signed representation. 8-bit signed representation, what will be the answer? It is 0, 0, 111. What you have to do? Whatever is there in the signed bit, increase 4 times. Right? Both answers are correct. This is 4-bit representation. This is 8-bit representation. So if the MSB is 1 here, if this is 0, we increase 0 4 times. In this case, this is 1, we increase 1 4 times. Okay, is it clear to all of you? For 16-bit, increase 16 times. Okay.
Sir, excuse me, sir.
Right. Yeah.
Sir, I'm having a doubt how to find out 2's complement for 1001.
1001. Okay, we will take after this example we will take that. Okay. So let's complete this multiplication process in detail. 1s 2s complement again we will study. Okay, don't worry. Now you understand this. Is this process clear? If you increase the signed bit towards left, okay, 4 times for 8-bit representation and still 8 more times for 16-bit representation, right? Okay. Now we will take the same thing over here. We are multiplying these two numbers. We have stopped here, you see. So here we have no bits. Here we don't have any bits. Here we don't have any bits. Is it clear? I would like to make the first this one 8-bit. Okay. So always remember, if you are multiplying a 4-bit binary value with another 4-bit, answer will come 8-bit. Okay. If you multiply n bit with n bit, you will get twice of that. Okay. You will get twice of that. So answer will be 8-bit. Okay. So let's increase this 1, 1, 1, 1. Okay. Now for the second one, let's take another color. I have increased. Okay. So I'm increasing based on this value, right? Now for the third one, it's not visible this color. Okay. Now for the fourth one. Okay. Now all are 8 bits. All are 8 bits. Now you add them. What you will get? You will get here 1. Okay. Try to add it yourself. 1 1 0 and a carry here 1. Okay. All of you observe here. Okay. The second one, 1 plus 1 is 10. Okay. I mean 1 0. So 0 is here. 1 is carried over. Okay. 1 plus 1 plus 1. Sum 1 carry 1. Okay. Now 1 plus 1 plus 1.
Carry 1.
Okay. 1 plus 1 plus 1. Sum 1 carry 1. Now 4 1s are there. 1 plus 1 plus 1.
Carry 1.
Okay. So 1 plus 1 plus 1 plus 1. 4 1s are there. Means what? Answer should be 4, right? 4 1s if you add in decimal, answer is 4. What is binary equivalent of 4? It's 100. This is binary representation of 4. So 0 will be here and this 1 0. Okay. So 0 I have written here. This 1 0 I have written like this. Okay. Is it visible? Let me write it in another color. This 1 0 I am writing here. Okay. Now add 1 plus 1 plus 1. How much? Sum 1 carry 1. Okay. Now 5 1s are there. If you add 5 1s, what you will get? Answer should be 5. 5 means what? 101. Okay. So sum 1 carry is 10. So that 10 will be written here. Okay. Like this. Like this thing. The 10 will be written here. Okay. So whatever is coming up to here, we can neglect, right? If you are getting more bits here, if you increase for 16-bit representations like this, okay, So these all will be the repeating things. Okay. So let's neglect these all. Okay. Now consider our result. Okay. What is the result here? This is the result. So what is its equivalent value? We'll see. What is its equivalent value? Is the multiplication clear to you?
Yes, sir.
We have to
Yes, sir.
convert all to 8 bits. Okay. So we have increased, rewritten 4-bit signed number as 8-bit numbers and added, because we are multiplying -5 with +7. Okay. -5 with +7. That's why we are following this approach. Okay. Now let's find out its equivalent value, because this is a signed bit answer. Okay. This is signed bit, right? I have taken signed bit representation. So it means what? This is, let me write, this is -128. Okay. Let me write it from here. This is what? 1, 2, 4, 8, 16, 32, this is 64. Okay. So what will be the answer? Let's write it's, which bits exist, you see? 128 plus 64, 32 not there, plus 16 plus 8 plus 4 plus 1. What is the answer? Find out. How much you are getting?
-35, sir.
Yeah, -35. Okay. We got the correct answer, right? We were finding answer for -5 into 7. Is the process clear to all of you? Signed binary multiplication, we have multiplied a negative number with a positive number. Okay, we have multiplied a negative number with a positive number. Okay, let's do it for the other one. I will multiply -5 into -7 and let's see what we are getting. Okay, -5 into -7, let's see what we are getting. Quickly we will do. We are left with 10 minutes. So I'm using this all. Now here 2s complement will be required. Okay. So let's do it. Yeah, we are interested to find out -5 into -7. Okay, -5 into -7. Now whenever this second number, okay, whenever this is negative, we will follow the approach what we are going to learn now. Okay, whenever this is positive, how to do, we have already done. Okay, -5 into +7. When the second number is negative, what we have to do, we have to complement the last product. Okay, we have to take 2s complement of the last product. Means what? Let's see. Represent -5 using signed 4-bit signed binary representation. So what will be -5 equivalent? It is 1 0 1 1. Is it clear? -7. What will be the answer? This is -8 plus 1. Okay. Now let's multiply these two numbers. Okay, let's multiply these two numbers. You're interested to multiply these two. Okay. Now observe carefully. I'm multiplying with this last one. Okay. What we will get? 1 0 1 1. Okay. What we will get? 1 0 1 1. Let's write in smaller font. We require more space here. Okay. Now multiply with the second element. Second element is what? 0. Okay. Second element is 0. The second element. So if you multiply with the second element, what you will get? 0 0 0 0. Okay. Now multiply with the third element. What you will get? All zeros again. Right. Now multiply with the last element. Okay. Multiply with the last element. So what you will get? Sorry. Multiply with the last element. What you will get? You should have got how much? 1011. Right. As per the earlier process, we should have written here 1011, but we won't write this. Okay, we won't write this. What will be the change? We will write 2s complement of this product. We will write 2s complement of this product. We have to write 2s complement of last product. Okay, last product. So here it won't be 1011. Okay, right. So what will be the answer here? The last product. Let's find out here. Last product would have been 1011. Okay, 1011. Now what is its 1s complement? It will be 0100.
0 0.
What will be its 2s complement? 0101.
0101.
So we will write this 0101. Okay. Now make all 8-bit. Okay. Now this is not there. These two are not there. These three are not there. Okay. Now we have to make 8-bit. This 4-bit signed numbers as 8-bit. So what I will do for the last one? What I will append? So here signed bit is 0. So I'm appending a 0. Here signed bit is 0. I'm appending 2 zeros. Here signed bit is 0. I am appending 3 zeros. Here signed bit is 1. I am appending 4 ones. Okay. Is it clear? Now take sum. Okay. This is 1. This is 1. This is 0. This is 1 1. 10. Carry 1 here. Again 1 plus 1. Okay. This is 0. Carry over 1. 1 1 1. Sum 1. Carry 1. This is 1 1 0. Okay. 1 1 0. Carry 1. So neglect the carry. This is the answer. Signed bit answer. What is its equivalent value? 1 2 4 8 16 32. It's 32 plus 2 plus 1. How
35.
much? Okay. Minus 5 into minus 7. Got it, right? Is it clear to all of you?
Yes, sir.
What you supposed to remember here is complement. Okay, 2s complement. The last product. The last product. What is the last product here? Okay. When it is done, when we are multiplying a positive or negative number with a negative number, if the second number is negative, if the second number is negative, okay, so it is applicable to minus 5 into minus 7. You people try this one, 5 into minus 7 in home. Okay, and tell me the result tomorrow. Okay, so I have done first one, minus 5 into plus 7. Okay, the first method. Second method I did for minus 5 into minus 7. Third method or third example was 5 into minus 7. It will be similar to the recent one what we have solved. You have to come 2s complement the last product. Okay, I guess it is clear to all of you. Is it clear?
Yes, sir. Yes, sir.
Right. Okay. So we will stop at this point of time. Okay, it's 9:57 now. So CRs, just take care of attendance. Today's quiz will be loaded. Okay, by afternoon or evening. Do respond it by the night, today night. Okay. Along with today's quiz, I will update the quiz 1, 2, and 3. Okay, 3 was there with some error. Quiz 1 and 2, and today's quiz 5 you will get. The 3 quizzes you respond to. Okay. Thank you very much. CRs, take care of the attendance and send. all of you please go through the process. The video lectures also I will upload today in the blog. Okay, you can watch it on YouTube on demand. So just go through it again and again and clarify yourself for the procedures, right? Is the attendance part over? CRs, shall we end the meeting or we'll wait for some time? Many people have left the meeting, I guess.